Okay, welcome. Multiplication and division equations, page 447. Should have your book out. You should be looking at the examples and taking notes. Remember, while taking notes, you don't have to write everything down, but make sure you write down the most important stuff. First things first, essential question. What does it mean to say two quantities are equal? Well, that means that's the equation. Okay, and we talked about that in the previous lesson. When you have two sides that are equal, two quantities, two expressions, that's an equation. Okay, we have our first vocabulary word, coefficient, which is an old vocabulary word. That would be that number next to the variable, like 3x, so 3 meaning the 3 is the coefficient. Okay, but it's a review, and we're still going to deal with lots of coefficients, especially in this lesson. Okay, so let's take a look at our first example number 1. Now, all of these properties of equality have to do with solving equations, or at least right now they do. And we're doing the same thing to both sides. And this time, the division property of equality means that we're going to divide on both sides of the equation. And our first equation is 20 equals 4x. So to solve, 20 is equal to 4 times x. The opposite, remember that's what we do in solving equations, is we do the opposite. The opposite of multiplication is division. So we're going to divide 4 on both sides. Now, dividing and multiplying are different. These equations will be different because I don't want to get to 0. That was what we were doing when we were adding and subtracting. Now what I'm going to do is I'm going to divide by this 4. I'm going to get this x by itself because 4 goes in the 4 one time, or 4 over 4 is 1. And when I multiply x times 1, I get x. So it's a little different than when we were adding and subtracting. We wanted 0. Now we just want 1. This is where that identity property comes in. It maintains the x. So we have a couple properties going on here. We have the division property, and then we have an identity property that maintains. But what you do on one side, you do to the other for the equality. We're going to divide by 4. 20 divided by 4 is 5. And then you check your solution. Is this my solution? Is 20 equal to 4 times, and then my new number is 5? Yes, that's true. Therefore, that would be my answer. Here's another problem. You have a negative 8y, or 8 times y, is equal to 24. Okay, I draw my line. Division property of equality, divide negative 8. I want the y, so I need to make sure that I get rid of all negatives. Negative 8 over negative 8 is 1. I get that y by itself. That's what I wanted. And I do the same to the other side. 24 divided by a negative 8. Well, a positive and a negative. Negative 3. Okay, let's test it. Is that true? Does a negative 8 times a negative 3 equal a positive 24? Yep. So that's my answer. Okay, let's see if you can do the same. Do these two problems, and then come back when you are done. Okay, so here we go. Word problem. Now remember what we were doing. We were dividing on both sides. So, and we have an equation. So this word problem, you're going to have to write an equation, and you're probably going to have to divide on both sides. Okay, so we read it. Layla sent 574 text messages last week. On average, how many messages did she send each day? A couple of items that we need to do. She 574 text messages. Believe it or not, last week is important too. Average. basically we're going to need to know how many days are in the week for this one. So we know it's 574. So when I set my equation up, I know one side's going to be 574. My next side, I need to make this equal 574. I know that there are 7 days in a week. Let M represent the number of messages Leela sent each day. Well, each day, if I multiply 7 times the messages, I should equal 574. That should be it. This is my full week. This is my messages. Total 574. That's kind of what that means. So then you just go through and you solve it. Divide by 7 on both sides. Okay, this becomes M. 574 divided by 7 is 82 text messages. Okay, so 82 text messages. Here is another way to look at it. Each day, the messages out of 7. Okay, and so we look at this. This is 7 each day. This is one day. A total of 574. So all of these days will equal 574. So you need to figure out how many were per, for 7 days. So 7 times M, or 7 M's. You can look at it that way. That's that coefficient. 1, 2, 3, 4, 5, 6, 7 equals 574. So 2 different ways to look at it. Here's one for you. Try it.